I'm sharing my screen. Please confirm once it is visible. You are able to see the screen?
Yes.
Okay.
Visible, sir.
Okay then. So we have just discussed about the float data type in Java yesterday, and we have also discussed about something like IEEE 754 standard, right? So let us do a small recap. We usually know that the size of the float data type is 4 bytes. 4 bytes is what the collection of 32 bits. The first point is very clear. The second point is the default size is 0.0f. But if you want to represent any floating point value, for example, if you have a floating point like fa equal to 100.56, it is very imperative to suffix the floating point literal with f. Can be either the capital F in uppercase or F in lowercase. So this is very much mandatory, right? Then you can what? You can get access to the data type. Println. If you are not suffixing the floating point literal with the f, definitely you are going to get an error. Why you will get an error is that every floating point literal, okay, every literal which has both fractional part as well as the integer part, right? By default, it will be treated as what? It will be treated as the double value. Double. You are placing this, it will be treated as a double value by default, even though you are suffixing it with the d, or if you are not suffixing it with the d. By default, it will be treated as double. It is just like assigning the double value to the float value, because double is a larger data type than the float value. That's why you get error like incompatible types, possible lousy conversion from double to float. Okay, this value is being treated as a double value. So that is what happening behind the scenes. Right? So that's why it is very imperative to suffix the literal with the lowercase f or the uppercase f. Both are valid cases. Let me do the uppercase and see we are getting any issues or not. It is valid as well. Right? Now what is the third point? It is designed to store up to the 7 fractional values. When I say 7 fractional values, I'm talking about the scale. I'm talking about what? I'm talking about the scale. See, let us take a big floating point number. Let me take 1.23, something like this. Okay, I have taken a floating point number which has many fractional values. Let me run this piece of code. And if you see, if you count the fractional part, or the part that is after the decimal point, right side towards the decimal point, okay? If you count the number of digits, there are totally 7 digits, up to 7. It says up to 7. Sometimes it could be 6, sometimes it could be 5. And if you see, some numbers are getting eliminated. Some numbers are getting eliminated. And if you do something, if you just look at this, if you just focus here, the actual value is this, guys. This is a problem with the floating point representation. This is the actual value, and this is the output that you have got. Let us do the comparison. This is the output, right? This is output. You see the output in comparison with the actual values. Okay, you have dot. Okay, fine. 2 is same as 2, 3 is same as 3, 4 is same as 4, 5 is same as 5, and again 4 is same as 4, 5 is same as 5, and again 6. Internally the values are getting rounded off. The values are getting what? The values are getting rounded off. This is one of the reasons. So this is one of the reasons. If see, even this is something which is very much negligible, because when something is getting rounded off after the 5 fractional places, or after the 6 fractional places, it is very much negligible. You can ignore this completely. It will not make much difference. But if you have to use this in the banking application, you want to use the float data type in the banking application or any financial application, okay, these rounded off things, okay, these small changes gets added up. They gets added up, okay, to the significant change, okay? Because they get the small values gets accumulated together over the period of time. and when you take these values accumulated over the period of time, the changes are going to be very much significant. Because in India itself, we have almost, each and every bank, under each and every bank, there are at least about 1 crore customers. SBI is a very big organization in India. If they are using the float data type to store the balance or to store any kind of manipulations, right? So this rounded off thing are going to give them the big issue. The security, the data gets compromised, the data won't be consistent. That's why it is never recommended to use the floating data point in the banking application. Recommended to use the floating data, float data type in the financial applications or in the banking applications. Making sense? This is one of the reasons. So what is an alternative that we will understand? If in the interview room, if they're asking you, where can I use this flow data type in the real-time application? You should say, you should keep this in mind. Can I use the flow data type in the banking application? No, we cannot use the flow data type in the banking application. It is not recommended. Why it is not recommended? There are rounding off issues are there. The behavior is little bit weird. The behavior is little bit weird because this behavior is happening based upon the registry, based upon the internal storage. Even though this is negligible, but it is ideally not recommended for the banking application. This is what your answer has to be. Then what is an alternative? What is an alternative? You have something like big decimal is there. So this is the future topic. Big decimal is there. And alternately, you can also use integer. We will understand this after after some time. Right? Making sense? Yes, no? Say something. Yes or no? Are we good till here? Type something in the chat box. Let's keep this session interactive. Only 3 persons are there. Come on, everyone. Type yes or no in the chat box.
Yes.
Okay. I'm just checking if we are connected. Okay, now you see, we have understood the third point. Now you see fourth point. Single precision IEEE 754 floating point standard. Okay, what does it really mean? Single precision means any registry. You take any registry. When I say registry, I'm talking about the size. If any floating point number, if any floating number is getting converted to binary number, is getting converted to what? Converted to binary number. Okay. Converted to binary number. Okay, in a 32-bit registry. Okay. When the registry is converted, okay, when the registry is 32-bit, okay, you call them as what? Single precision. Okay. When the registry is 64-bit, you call them as what? Double precision. Okay. And when you have the registry with 16-bit, you call them as what? Off precision. These are just the names, alternate names. Because to convert the floating point number into the binary number, we are following a standard called IEEE 754 standard, right? And again, when this when the number is getting represented in 32-bit registry, I'm talking about the size here. It is also called a single precision. When it is getting registered, recognized with the 64-bit registry, it is called as double precision, right? So for double precision, you usually we have a data type called double data type. Double data type for the double data type, you call it as what? 64 double precision. In some languages, they represent a particular floating point data type to the 16-bit representation, 16-bit registry. So we also call them as off precision. Right? So this is what about the precision is. Okay. Now look at the next thing. Okay. These are the things that you can give in the interview room when you are specifically asked about the float data type in Java. Now look at this, guys, from the documentation. This has been collected from the documentation, right? If I am not telling you about this IEEE 754, what is IEEE 754 standard? See, look at the web pages. Okay, look at this web page. So there is a web page. What it says, look at this web pages. It says something like there is a specification about the float data type is a single precision 32-bit IEEE 754 floating point. You will not understand this. Why we are studying all this? You will never understand this. For each and every website, these things are there. Okay, so even here also it is there. Let me close this. Advertisement has popped up. Screen is blocking this advertisement. Okay, let me open the alternate one. You see, what is a float keyword in Java? The float keyword in Java is a primitive data type that represents a single precision 32-bit IEEE 754 floating point. So we study this blindly, but we don't really understand what does it really mean. IEEE 754 floating point. That's the reason why yesterday I have explained to you about the conversation. How do we use the IEEE 754 standard to convert the floating point number to the equivalent binary number? That's why we have studied that, right? So this is from the documentation, right? And it says it ranges of values is behind the scope of discussion. If you ask me, sir, what is the range of float data type? My answer would be very simple. My answer would be very straightforward. What I say, the range is not defined specifically. The range is not defined specifically. It depends upon, right? See, for the integer data type, we have the finite set of values. The numbers are very finite. From negative number to the positive number, the numbers are very much finite. You can count that numbers for the integer data type. Even for the long data type, you can actually count the numbers. But when it comes to float data type or double data type, we are giving importance only to what? Only to the fractional values. For example, you may be having integer value. Integer part can be like 1,23,045. But we are giving priority to the fractional part. Yeah, so we are actually giving priority to the fractional part. When you take float can represent up to 7 fractional digits. Up to 7 fractional digits, right? And when you take double, it can represent up to 14 to 15 fractional digits. 15 fractional digits, something like this. So the importance is given only for the fractional part, not for the integer part. And also you cannot you cannot conclude, because these fractional parts are like these are the infinite things. There is no standardized solution for the fractional part. It keeps changing. You cannot define a boundary for the fractional part, even because the significance is very less. It will not make much difference. That's why these are preferred using in the scientific applications. And the range is behind what? The range is behind our discussion, scope of our discussion. You don't discuss about the range when it comes to float and double data type. No, sir, still I want to know the range. How I can find the range? How I can get to know the range for the float data type? Yes, you can get the range. Let me go back to the compiler. Now focus here. So there is a formula for that. My intention is you do not want to memorize that. System.out.println. The formula is like float dot maximum value, float dot minimum value. So this is the formula. That is float dot min underscore value. Okay. In this way, you can capture the minimum value of the float data type. So this, it says it is a minimum value. Okay. And you want to find the maximum value. Yes, you can also find that maximum value. But the question is, do you think that this minimum range and maximum range is within the scope of our discussion? You are able to see a letter like E here, right? E is representing what? E to the power of 38. E to the power of 38, which means, so it is going to store a very big number considering the integer part as well as the fractional part. Likewise, if you see here, E is representing what? E is E to the power of minus 45, which means it is going to store a very small number considering the integer part as well as fractional part. That's why the scope is behind the discussion. It is not necessary to understand the minimum max value. Still, you want to find that, you can find it by using this float dot min value. There is a class called float class, and there is a constant called min value. If you use this in the system.out.println statement, you will get the min value and you will get the max value. Not only for the float, you can get all the values for byte, for short, for long, your intention is not to memorize, and still you want to find the min and maximum value for the byte data type. Okay, for the byte, okay, now you see you get minus 127 is the minimum value, plus 27 is a positive value for the short data type. Okay, so this is how you can find if your intention is not to memorize. Okay, short dot min value. Likewise, you give what? You give short dot max value. Okay, for the short, you are getting the minimum value and the maximum value. Likewise, even you can find for integer, you can find for long, you can find for float. Okay, you already found for float, you will find for double, and you can also find for what? Character. Character data type. So character is what? Is an unsigned data type. I mean, it's an unsigned data type, right? Not signed. So minimum value will be starting from 0. We will see one by one. Okay. To calculate the minimum value for byte, and this is for short, this is for long or int, let us say. Okay. Integer. We will use the complete class name. Okay, we don't use the primitive type. We will use the class type here. And there is long. There is also long. Okay, and you have float. You have a double, and here you also you have what? You have double, and you have character. Let me print this. Okay, this is the range that you have got. Okay, for short, range minus 128 to plus 27 for for byte, for short, for int, for long, for float, and this is for what? This is for double. And if you see for the character, so it is giving something like 0 and a question mark. If you ask me, okay, if I have to say what is the minimum value for the character data type and what is the maximum value for the character data type, I have to say, I have already said you, character data type is following what? It is going to store the letters in the form of Unicode, right? Okay, the minimum Unicode is what? /u 4 zeros. This is the minimum value. Okay, and the maximum value is what? Okay, /u f should be in lowercase. Okay, this if you convert this, you get something like a space, and if you convert this, you will get a value that is not getting converted directly. So this is the minimum value and the maximum value for the character data type with the Unicode representation. It is getting represented in the form of Unicode. And again, if I ask you a question, what is the minimum value for Boolean data type and what is the maximum value for the Boolean data type? Do you have any answers for that? What is the minimum value for the Boolean data type and what is the maximum value for the Boolean data type? Anyone can answer this? Any idea? Okay, at least tell me what are the values that the Boolean data type can store?
Yes, no.
Yes, no, true, false. Only true or false. True, false. So if for any such thing, okay, when you have a data type that is storing only true or false, so it means that there is no such thing like the minimum value and the maximum value. If I try to do this, okay, you will get something like what? See, you will get an error because there is no concept of min value and no concept of max value for the Boolean data type. It can store only one number, true or false. You cannot say true is a minimum or maximum. You cannot also say that false is a minimum or maximum. So both have its true and false. You know, they are just a kind of standardized values. There is no such thing like minimum or which one is minimum or which one is maximum. So this is not applicable for Boolean data type. Okay? All this you can use. To find the minimum and maximum value when your intention is not to memorize. So really you do not have to memorize all these things. Okay, this is just for if you are getting this kind of questions in the interview room, you can, if you don't remember, you can say this, because ideally no one will remember this. Okay. Okay, now the next thing. If you remember yesterday, We have understood how to do the conversion from floating point number to the equivalent binary number by using IEEE standard. Now today, let us say that I am giving you a binary representation, a 32-bit representation, okay, representation of what? Representation of binary number, IEEE 754 binary number. This is a binary number that has been stored by using IEEE standard. I want to convert this to the decimal number. Yesterday we have understood the conversion from floating point to 263.3 we have used, I think 263.3. This number has been converted to equivalent binary number, okay, by using IEEE standard. IEEE standard. So if you just watch that video for the better understanding. Today, if you get any binary number which is represented in IEEE standard, if you want to convert this to the equivalent decimal number, what is the procedure? This procedure is very, very simple. Okay? Very, very simple and easy to understand. Pay some attention. Okay. So when you get a 32-bit registry, how I can confirm that it is a 32-bit registry? Just count number of bits: 4 plus 4, 8, 12, 16, 32. 4 plus 4, 8, 12, 16, 20, 24, 28, 32. Totally there are 32 bits, right? So the first bit is always reserved for the signature. I can conclude one thing here. By looking at the first bit, if the bit is 0, I can say that, okay, the number is a positive number. Whatever the number is, I can conclude that, okay, the number is a positive number. First conclusion. It must be a positive number. At least we should be in a position to conclude that. And also, next consider the next 8 bits. Okay. This bit is representing what? This bit is representing the exponent part. Exponent. Okay, the remaining 23 bits are representing what? They are representing the fractional part. So in computer terminology, call this as what? Mantissa. These are the things that we have discussed in the colleges. Mantissa or fractional part. Fractional. Now I want to find the what is the value on this exponent part. So let me take those bits. You have 1 0 0 0 0 1 0. So this is a number that you have. Okay, 1 0 0 0 0 1 1 0. Okay, raise the powers. What you will do? You will just raise the powers. Focus here. 2 to the I take 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, okay, and 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. I'm not considering this because every bit is what? Everything is a 0th bit, right? So I will not consider that. I will consider this one, I will consider this, and I will consider this. So it is going to be like 2 to the power of 7, okay, plus 2 to the power of 2 plus 2 to the power of. What is the answer that we get? Anyone help me? Anyone? 134, huh?
134.
Yeah, 134. So we get 134. Yesterday we have also understood something about a concept called bias. Okay. So the value of bias is 127. And what else we have understood from the bias? If you get the exponent as a negative one, there is a exponent can be a positive number or it can be a negative number. Okay, if the exponent is a positive number, for example, let us say that the exponent is something like you have number 8, right? You add 127 plus 8, you will get something like 135, isn't it? Okay, and you convert this 135 into the equivalent binary number, and you place it here, right? And if the exponent is -5, something like that, you just subtract it from bias. 127 minus 5. What is it? What is going to be what? 122, right? So this 122 will be converted to the equivalent binary number, will be placed here. Now we are going to do the opposite. We are going to do what? We are going to do the opposite, right? So you got 134. This 134 is nothing but the combination of 127 plus what? Combination of bias plus one x value. There is an x value. This is exponent value. Combination of bias plus exponent value, which is going to give, which is 134. This 134 is nothing but the combination of bias plus some exponent value. We don't know what is that exponent value. So you need to calculate, you need to find x. 134 equal to 134. Right? So again, x equal to what? 134 minus 127. Okay. What is the value of x now? If you do this, you get 7 now. Okay. Now we have found that the exponent is what? The value of exponent is what? 7. If you don't understand this, watch my exercise video. So we have we have used bias and we have manipulated this bias based upon the number that we have. If it is a positive number, we did addition. If it is a negative number, we did subtraction. So we are just doing the reverse thing. So we are just extracting the exponent from the value, which is 134, and we are removing the bias here. We are just removing the bias, which is 127. So you get the actual exponent value. Okay. Now second thing is, first of all, we are able to find the number whether it's a positive or negative number. The second thing is, we are able to find the exponent value. Exponent number. And the third thing, we need to find what? We need to find the fractional part or the mantis. Now focus here. This is also very easy. This mantis or fractional part. Okay. So this is representing the fractional part. Yes or no? This is representing the fractional part. When something is representing in the form of fractional part, okay, when the binary number is getting represented in the form of fractional part, you raise the powers, but the power raising has to be like this: 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3. For the positive numbers, you do what? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. This is the pattern for the positive binary number. For the negative binary, for the fractional part binary number, so this is the pattern. Okay, what is the pattern? 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3, 2 to the power of minus 4, 2 to the power of minus 5. Okay, and there are no more ones, right? So everything will be what? 2 to the power of whatever the value is, they are not countable, okay, because they are on top of zeros, right? So I can take only the 3 values, which is what? 2 to the power of minus 1, because 1 is getting represented, and 2 to the power of minus 3 and 2 to the power of minus 5. Okay, focus here. 2 to the power of minus 1, okay, plus 2 to the power of minus 3 plus 2 to the power of minus 5. Right? This 2 to the power of minus 1 can also be like, you can do what? You can do the alternate conversion. You can convert this 2 to the power of minus 1 like it is similar to 1 by 2 to the power of 1. This is similar to 1 by 2 to the power of 3. And this is similar to 1 by 2 to the power of, right? And which is what? After the evaluation, you get 1 by 2 plus 1 by 8 plus 1 by what? 32, no? 2 to the power of 5. Right? 1 by 2 is what? 1 by 2 is going to give us 0.5 plus 1 by 8 is what? 1 by 8 is going to give us 0.625, right? And 1 by 32 is going to give us 1 divided by 32. 0.01325. 0.01325. 0.01325. 0.0. I'm sorry. 0. 03125. You add all these numbers 0.5, 0.62. Let us see what we get. Plus 0.5 plus 0.625.
1.15625.
Yes, 1.15625. Let me do this once. 0.5 plus 0.25 plus 0.0312. 1.15625. Okay. 15625. This is equivalent to what? This is equivalent to 1.15625. Right? So this is a number that we have got. So after this, what we will do? Okay, there is a formula called minus 1 whole to the power of s. Okay, into 1 plus m. Okay, into 2 to the power of exponent. Okay, this s is representing what? This s is representing the whether it is a positive number or the negative number. If it is a positive number, you replace this s with 1. If it is a negative number, you replace the s with 0. So we have the positive number, right? So you replace this with 1. Okay, 1 plus m. This is the mantissa. You perform the addition. Okay, any minus 1 to the power of anything power of 1. I mean, sorry, I'm sorry, guys. Positive number is representing 0, right? Not 1. It is representing 0. Not 1. Because MSB, according to the MSB concept, the positive number is representing 0. Right? So you replace this s with 0. So anything to the power of 0, anything to the power of 0 is 1 into 1 plus m. So 1 plus m is what? Mantissa. 1.15625. Right? Into 2 to the power of, what is exponent number that we have got? Value of exponent is what? 7. 2 to the power of 7. Okay, you get what? 2.15625 to 2 to the power of 7. If you convert this, you will get a number. So 2.15625, 2 to the power of 7 is what? 128. 128 into 2.156. Let's do. $2.15625. $276. So this is the equivalent binary number. Okay. This is the equivalent binary number. Okay. So do you think that do we need to remember all these things? So this is not necessary for you to practice or do anything. You just understand what is the IEEE. That's it. Converting from converting from decimal to binary, and converting from binary to decimal by using IEEE 754. So we need to understand that. So these are the internal things that will be taken care by the compiler itself. But the registry, this is how the registry is storing the values. And this is how the values are extracted from the registry to give the equivalent decimal number. So because of this only, there is a loss of, because of this mantissa, there is rounding off is happening. Okay, because of this mantissa, it is able to represent only 7 values in the fractional part. Because of this mantissa, there are some loss of values for the fractional part, because it cannot hold all the numbers, all the fractional numbers. So there is a limit for this. This limit is ensuring that the rounding off is happening. The the some fractional numbers are missing. Okay, some what we call it as some things that we really need to consider is not taken care by this mantissa part. That's why this floating point is not used. This float data type is not used in the banking applications. If you have time, you can go through this once, but don't spend much time on this. Okay. Now, what is the next thing? Next thing is what we have understood what is a float data type. Now let us understand what is double data type. Okay, double data type, the last data type. Double. Data type. So again, what is a double data type? We will understand about the size. The size of the double data type. Size is 8 bytes. Okay, 8 bytes is collection of how many bits? 64 bits. The second thing is the default value. The default value of double data type is, what is the default value? 0.03. It is just like this. When you take a double data type, for example, we remove all these things. Okay, and you take double d equal to, or double a equal to something like 100.00. I'm not specifying anything. I'm not suffixing anything. Println. I'm not suffixing whether it is a d at the end in the literal. I'm not suffixing d, small d or capital D. But still, you don't get any issues from the compiler, because by default, whether even though you place or you don't place, by default the number with the fractional part will be considered as a double in Java. You take any number, okay, if you want to store any number like this, 123.567, any number, any fractional part number, okay, any floating point number, by default the Java will consider all the number with the fractional part as double. It will treat it as double. But when you want to specify it, okay, when you want to make a differentiation that this is not a double, then you do what? You just suffix it with f. You're suffixing the value with the f. It means it is you are giving much specification that this is representing the float data type. You are trying to use the float data type. If you're not specifying anything, if you're not suffixing this with any other letter, by default it will be considered as double. But still you have an option to suffix it. But still you as a developer can have an option. You can suffix it with d, small d or the capital D. There will be no issues. But if you don't suffix it, no issues. It will be treated as a double. Okay. If you suffix it with this value, this letter will be treated as a float value. Now remember one thing. So this will be treated as a float value. Right? You are assigning this floating point literal to something like double. Do you think we will get any issues? We will not get any issues, because the smaller data type is getting assigned to the bigger data type. In this case, you will not face any issues. Only if you do the opposite. If you do the opposite, you will get the issues. Okay, and default size is 0.0d. Okay, and let's talk about the default size. To understand this default size, I am taking a variable like static double test. Okay, I'm not assigning any value to this test variable. I just want to print that. I want to access that variable. I'm accessing that variable directly, test. Okay, when you access that variable directly, what you will get? You will get a default value. But look at this, it says only 0.0, where d is missing. You don't see the suffix d, but internally, it is considering the d as well. Compiler is considering the d as well, but it will not get printed on the console. So when someone is asking what is the default value of double data type, you should say it's 0.0d. You should not you should not miss this suffix. Third one. What else we have? Okay, the size is not precisely defined. Again, here also the size is not precisely defined. It's not a topic of discussion. It is out of our scope to discuss. Defined. Okay, and the fourth one. But still, if you want to find size of for the floating point for the double data type, so this is you can use this. Okay, and the fourth one. Fourth one is what? See, go back and see for the float data type. It's a single precision IEEE 74 floating point standard, but here it is double precision. Double precision because it is getting stored in the 64-bit registry. Double precision. Full precision IEEE 734 floating point standard. Floating point is not like the float data type. Floating point is a representation. Float data type is different. Floating point standards are different. Floating point is a data representation. Okay, don't get confused. What is the last point that we can take for the double data type? So the range we have discussed. Okay, the size we have discussed. What else we need? That's it. I think these four values are okay. Suffixing is an optional. Let's take this. Suffixing. Fixing the literal with optional for the floating point data for the double data type. Okay, then what else we have? That's it. Now I will ask you a few questions. Just try to think and answer. Okay, think and answer. Don't answer it just like that. Okay, if I ask you what is the smallest data type, what is the smallest primitive data type? Just primitive data type in Java. What is the answer? Anyone? Second question. How many primitive data types are there? At least answer this question. In Java. The third question. What is the largest primitive data type in Java? Primitive data type. Okay, fourth one. List out the primitive data types in. Come on, answer. You can answer either you know or you don't know, so that I will explain. First question, what is the smallest data type? You know or you don't know? Byte. What about others? Okay, let me give the answer. The smallest data type is the Boolean data type. We have just discussed, no? Boolean stores the range of Boolean is what? True or false, but its size is 1 bit. You remember in the first class we have discussed that. Prasanna, are you good? Are we good? Forgot, no?
Yes.
Yes. How many data types are there in Java? Can you answer this question? How many primitive data types? Very much countable. 8 primitive data types. Primitive data types. Okay. What is the largest primitive data type in Java? Can you answer this? Okay, before answering this, let us list out the primitive data types. Okay, you have byte, you have what? You have something like short, you have integer,
Short, int, long, float, double, boolean, char.
Yes. Char and boolean. If anyone is asking you, what is the largest data type in Java? If anyone is asking you, so there is a condition.
Boolean, sir.
Largest boolean, largest.
No, long.
Okay, you have answer. You can answer long. That is also agreed. Can you also answer double also? Two data types are
Yeah,
coming
we
into the
can.
picture. But the question here is, if you are asking me what is the largest primitive data type in Java, I would say double. Why I would say double, I will explain you. And also, you should ask the follow-up question. What is the largest primitive data type in Java? You should ask them, are you talking about the size? When you talk about the size, long will come into the picture as well as double will. Both answers are correct. When you talk about what? When you talk about size. But there is something like a promotion chart. This is very, very important. There is something like a promotion chart. What is promotion charts? Okay, this is how the promotion chart looks like. Promotion chart. Okay, first, always, okay, in the promotion start, remember, Boolean will not, Boolean is not participating in the promotion chart. It's not chart, it is chart. Promotion chart. Boolean data type is not participating in the promotion chart. It is very special data type. It will be sitting somewhere ideally. It is representing only true or false, right? So there is no requirement for this Boolean data type to participate in the promotion chart. It says I will be not participating in this promotion chart because I am storing only two values. One is true, second one is false. Because it has no concept of minimum value and the maximum value. That's the reason why, right? But the promotion chart says, right? Okay, the next biggest value is short, and again the next biggest value is integer. The next biggest value is long, and your next biggest value is float, and your next biggest value is, okay, and you have character, char, right? Character will be somewhere here. Character will be somewhere. Okay, this is the ideal promotion chart. Okay. And we are experts now. We are experts in the size calculation, right? We are very much experts now. Okay, it is one byte, 2 byte, four bytes, 8 bytes, 4 bytes, 8 bytes, and this is 2 bytes. My question is, if I ask you what are the largest data types in Java, blindly you can say long and the double according to the size. According to the size, you are completely correct. Long and the double. Long and double. But according to the promotion chart, if anyone is asking you what is the largest data type, you should say double. Why it is double? When I ask me if I want to give you the real-time analogy, see, we have done the colleges, right? We have done with the college. So during our graduation, you know that we have the professor or we have the lecturer. Okay. So lecturer reports to what? Lecturer reports to the head of the department, HOD. Okay. HOD reports to vice principal. Vice principal reports to principal. Principal reports to chairman. This is the hierarchy. But I can also say that, okay, when I was doing engineering in my college, the age, when you talk about the age of the HOD is same as the age of the principal. So HOD is 60. He was 60 years old at that time. The principal, he was also 60 years old. But you cannot say that since both are possessing the same, both are falling under the same age category, or both are possessing the same age, I cannot say that both are same. We do what we consider the experience here. HOD may be having only 15 years of experience, but the principal might be having 20 years of experience. According to the experience, according to the knowledge, according to the experience, okay, no matter what the age is, if the age group is same, no matter, okay, it will not be considered to define who is greater or who is not greater. According to the experience, we consider, okay, this principal is what greater than HOD. Because of age? No, because of the experience. Likewise, if you see, even though long is capable to store 8 bytes of memory and double is also capable to store 8 bytes of memory, I cannot say both are same, because double can store possibly large combinations of values. Sometimes bigger integer part as well as bigger fractional part. When you combine the integer and the fractional part, okay, double has the huge amount of capacity. Double is very much capable to store larger integer part as well as larger fractional part. It can do two jobs. If you give me integer, I will store integer part also. If you give me fractional part, I will also store fractional part also. If you give me combination of integer part as well as fractional part, I'm good enough to store that also. But when you say long is capable enough only to store the bigger integer values, not the fractional values. Even though the size is same, if you see the work that they are doing, if you see the long and if you see the double, if you compare them by the values that is being stored in long as well as in double, so the double is something very special than long, right? It is capable to store huge range of values from fractional part, negative fractional part to positive fractional part, and also integer part as well. That's why by promotion chart, you should say double is the larger data type. The question should be, in what context you are asking. If you are asking about the size, I could say long and double. If you're asking about the promotion chart, okay, if it is by promotion chart, I could say it is double, only double. Are we clear so far? This is the answer. Yes, no, everyone? Are we good till here? Are you with me?
Yes.
Okay, then. Now what else we have? I think we have completed promotion chart also. Yes. I think we are good to close. Now tomorrow onwards we will discuss about what? We will discuss something like yeah, operators. After completing operators, we will do a small application, a very simple application to understand all these things, how it works in the real time. Okay, that's all from my side for the today. We will meet